Okay, let's continue still on annuities. So we've discussed the two types in the previous video. Now we still have other types or situations or conditions. Okay, so next would be what if we have an annuity and we need to we are required to solve for the future value of this particular series or periodic payments, so the same principle, uh, to calculate or to arrive at a certain formula. Sinulat ko na yung formula natin, okay, para hindi masyadong mahaba yung video. um, Using the previous formulas that we had before in compound interest, ang gagawin natin is that we are going to calculate the future worth or future value of each of these periodic payments. So sinabi ko kanina, usually annuities or periodic payments are actually paid at the end of each period. So from 0 to 1, ito yung payment niya, 1 to 2, and then so on. So meron tayong annuity at the last. Ito. Okay, or may payment tayo at the last. Okay, so what we're going to do is to transfer, hindi naman transfer, we just compute for the value of each periodic payment sa may future worth niya at a certain time. So for example, ito and may 1, kunin natin yung value niya in the future, and then ito, and so on. If we do that, we will be arriving with this equation or formula to solve for the annuity, the required annuity. Ito ba yung, sorry, hindi pala to question mark. Sabi ko kanina is given itong given, ito yung formula natin. So if we, pag meron tayong given yung future worth, what would be the periodic payments that I would be paying so that may marireceive ako at the end of a certain period of time na ganitong value. Okay, so ito yung babayaran ko for every period, so that in a certain period of time in the future, I will be receiving this amount. Okay? Ayan. So we call this the term in the bracket. Ito yung itong naka-bracket, naka-enclose sa bracket. We call this the sinking fund factor. Okay, sinking fund factor ang tawag natin dyan. So ito, importante rin ito when we try to solve later on yung mga tawag dito, nag-solve tayo ng mga ng depreciation values or cost. Later on we will be applying these concepts also. Okay, so we call this a sinking fund factor. Ito naka-enclose sa my brackets. Okay, next is what if given itong periodic payments natin, ito series of periodic payments. Okay, what will be the future worth of that of those periodic payments? So if that is the case, we will simply manipulate this formula. So given ngayon yung periodic payments na A, then we solve for F, then cross multiply lang. Nagkabaliktad lang ito. So cross multiply lang natin, then ito na yung formula natin to solve for the future worth of this series or this periodic payments. Now the term na naka-enclose sa bracket, we call this the uniform series compound amount factor. So we call this the uniform series compound amount factor. Itong naka-enclose sa bracket. So ito, we call it the sinking fund factor. Ito, the uniform series compound amount factor. Okay? So yan. Let's try to solve some problems, illustrative problems. Okay, so we have number 1. The president of Sarao Motor Company wants to know the equivalent future worth of a 50,000 pesos capital investment each year for 8 years. Starting 1 year from now, Sarao Capital earns at a rate of 14% per year. So meron tayong 50,000 capital investment each year. So mag-invest yung Sarao Motor Company ng 50,000 per year. Now, for 8 years. Okay. Gusto niyang malaman magkano kaya wrong spelling. So magkano yung worth or value ng investment niya na 50,000 per year, okay, at the end of 8 years. So Sarao Capital earns at a rate of 14% per year. So we are solving for the future worth of this periodic payment of 50,000 pesos. We have so ang periodic payment natin is 50,000. Interest rate natin is 14%, should be in decimal form, and that would be in 8 years. So the future worth of this investment, yearly investment of Sarao Motor Company is equal to, we have 661,300, no, that is 638.0079. Okay, so ito yung amount or yung future value or future worth of this yearly investment for 8 years. Okay, ayan. Okay, next, second problem. Mr. Franklin wants to save for new sports car that he expects will cost 1,900,000 in 4 years from now. Okay, how much money will he have to save each year and deposit in a savings account that pays 6.25% per year compounded annually to buy the car in 4 years? So yung presyo ng car, yung sports car na gusto niyang bilhin after 4 years, so na predict niya o na-compute niya siguro, that would cost him 1,900,000. Okay, so magkano ang ide-deposit niya yearly, monthly, yearly, para magkaroon siya ng 1,900,000 after 4 years at the rate of 6.25%. Okay, so we are solving for the annual deposit to meet the desired amount, which is after 4 years, which is 1,900,000. Okay, so we have the future amount is 100 million, 1.9 million. Interest rate is 6.25%. For 4 years. So the annual deposit should be 432,716.1523. This should be the annual deposit that should be made every year, so that after 4 years he will have an amount of 1,900,000 to buy the car. Sports car, no? Okay. Okay, next problem. A computer engineer wishes to set up a special fund by making uniform semi-annual end-of-the-period deposits for 20 years. The fund is to provide 100,000 pesos at the end of the last 5 years. So take note, last 5 years, hindi ko na ilagay dun sa module yung 5 years. For the last 5 years, yan, of the 20-year period. If the interest is 8% compounded semi-annually, what is the required semi-annual deposit to be made? So we have two cash flows involved here. So the first cash flow is that yung semi-annual deposits. Ito yung illustration natin. A more detailed illustration ay nasa module. Okay, ito yung cash flow natin for the first condition. So every or twice a year, that's why this is 40. Yung bilang ko dito is 40 because the payment is or the deposit is made twice a year. Okay, that's why this is 40, but this is actually 20 years. Now this is counted in terms of the number of payments, not the number of years. Itong first cash flow. So I repeat, this is counted in terms of the number of payments, not in terms of the number of years. That's why this is 40, but this is actually 20 years because the payment is done or the deposit is done every or twice a year yung deposit natin. Okay, so meron kang semi-annual payments, yun yung unknown natin. Okay. So, ano dapat yung semi-annual payments ko so punta tayo dun sa second na cash flow at the last 5 years of the 20 years na nag-deposit ka. So, for 20 years, you are depositing a certain amount. Okay, so ang goal mo is that for the last 5 years of the 20-year period or time, makaka-receive ka ng 100,000 each of the 5 years. So sa 16th, ibig sabihin sa 16th year, meron kang 100,000. Sa 17th year, meron kang 100,000 and so on up to the 20th year, meron kang 100,000 pesos. So ang question is, ano dapat yung semi-annual payments na deposit ko so that I will be receiving this amount at the last 5 years of the 20-year period. Okay, so with that, so since we have two cash flows, so that would be our clue sa gagawin nating solution. So we'll be using the economic equivalence concept to solve for the annual or the semi-annual deposits. Okay, so we will use the equation of value to solve for the semi-annual deposits. Okay, and we need also to look into the interest rate. So the interest rate is 8% compounded semi-annually. Okay, yan yung interest rate natin. Okay, so if that is the case, the semi-annual interest, convert natin to. Kasi ito yung interest rate, this is the nominal rate of interest. Ang tawag natin dito, recall natin yung mga terms natin in terms of interest. We call this the nominal rate of interest. Okay, so the interest, semi-annual interest would be, solve natin. We simply divide it by 2 since semi-annual yung ating number of compounding. So we have 8% divided by 2, then we have a 4% semi-annual rate of interest. Next, of course, is since yung second cash flow, yung first cash flow natin, we need the semi-annual interest. Okay? So, second cash flow, since yearly ito, yearly. Ito kasi semi-annual, yung first na cash flow natin, semi-annual. Second cash flow is yearly. So, we need also to solve for the equivalent interest rate in 1 year. So, we need to solve for the effective rate of interest of this 8% compounded semi-annually na interest rate. Okay? So, the interest rate, the effective rate of interest is equal to semi-annual, no? So, the effective rate of interest, which will be used later on for this particular cash flow, is equal to 0.0816, or that is 8.16%. Okay? So, again, ito na interest gagamitin natin for the first cash flow since it is semi-annual. Okay? The deposits are made semi-annually, and itong interest na ito, we will use this for the second cash flow since this is done annually. Okay. 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 So when we apply the concept of economic equivalence, we need a certain focal point where the calculations, no, of value, of worth, are based. No. So in this case, we can choose any point in the cash flow diagram, but I think it would be best if we choose the last year, 20th year. No. So 20th year. Okay? So let's use the last year as our focal point. So itong annual, semi-annual deposits natin na ito, A, kukunin natin yung value niya isa-isa papunta doon sa last year. Ano kaya yung future worth nitong first payment? Ano yung future worth nitong second payment? Ano yung future worth nitong third payment? And so on at the last year. Ganon din sa second na cash flow natin. Ano ang future worth ng 16th? Punta natin sa 20th. From 17, ano yung future worth niya? Punta natin sa may 20th. Okay? So, and we are going to equate both cash flows. So, ito muna ang unahin natin, ang equation nito. So, we are solving for the future worth. So, ano ulit yung formula natin? It's equal to okay, so to get the future worth of a series or periodic payments, ito yung formula natin to solve for the future worth. Okay. And yung both cash flows naman involves the calculation of future worth. Okay, so ito, first cash flow. We are solving for the value of A. So times 1 plus, and again, we are going to use the semi-annual rate of interest na 4%, so 0.04. Again, since this is done semi-annually, the deposits are done semi-annual. Pag sinabing semi-annual, you're going to deposit twice a year for 20 years. So, ibig sabihin, 40 times ka magde-deposit. So, yung value ng N natin is 40. Then, equate natin sa second. Ito. We're going to solve for the future worth of itong 100,000 na ito. Periodic na 100,000. We are going to use the effective rate of interest. Okay. Ito yung 1 year natin is 8.16%. And the value of N is 5 years since we start at the 16th year up to the 20th year. So 5 years ito. Okay. So we have one unknown in the equation, and that is the semi-annual deposits that should be made. And that is equivalent to 6,193.438 pesos. So ito yung required na semi-annual payments natin for 20 years, so that at the last 5 years, I will be receiving 100,000 pesos each year. So ito, kailangan nating i-deposit semi-annually. Okay.